So you could test some R values and see what happens to get an idea of what maybe the answer is. I mean, if you test out a bunch of R values, you might have an idea. It might some pattern might emerge. For example, you might try something and it might emerge. There are how many different R values to potentially test?
Infinite.
An infinite number. So what can we do? Here's something that's true, or you can tell me if this is true. Well, if you do a plus b and you square a plus b, what do you get?
A squared plus 2ab
Plus what?
b squared.
Plus b squared. You agree with that, right? Okay, so what happens if I compare that to 2a squared plus 2b squared? What happens if I compare this quantity to this quantity? If I compare those two quantities, what can you tell me about them for certain?
The one on the right is greater?
The one on the right is greater than
Or equal.
or equal to. Can you explain to me why? If they're both equal to, that's correct. But here's the thing: how do you know that this one could be bigger? What's the logic for it? Well, if you subtract a squared, yeah, go ahead. Go, Shuan. Yeah.
A squared plus b squared is bigger than or equals to 2ab.
Exactly. This is true because if you subtract a squared and b squared from both sides, you end up with 2ab and a squared and b squared. How do you know that the sum of these two is bigger than or equal to that? How do you know that?
Because a plus b is bigger than or equals to square root of a 2a.
Yeah,
Can
if you
subtract one,
2 square root of
subtract 2
Hold on a
AB
sec.
from a squared plus
you've seen some of this stuff, so that's totally fine. So do you agree with that so far?
Wait,
Okay.
Why is it smaller if it's squared?
Okay, this right here is just the same thing as that,
Oh, yeah.
except I've used y and z instead. Okay, are we okay so far?
Yeah.
So here's what I'm going to do. I'm going to take this right here. If I make this bigger, does it change the inequality?
No.
If I make the bigger side bigger, does that change the inequality? No. So ready? X plus y plus z squared is therefore less than or equal to 2 times x squared plus 2 times y squared plus. Do you agree with that? So let's clean that up a little bit. You get x plus y plus z squared is less than or equal to 2x squared plus 4y squared plus 4z squared. Now here's the thing. I don't really like having different coefficients. Is this also true? What about this? Can I just do this? Why? Yeah, I'm turning, this is true. 2x squared is less than or equal to 4x squared, correct? So all I'm doing is making this bigger. If I make that bigger, does it change the inequality? No, it doesn't. So now I have this thing right here. I have x squared plus y squared plus z. X plus y plus z squared is less than or equal to 4 times that. Are you with me so far?
Now can we safely say that x squared plus y squared
No, x plus y plus z to the r is less than or equal to, what do you think?
2 to the r.
2 to the r. No, that's an equally safe bet. That's an equally safe bet.
Say, sorry.
R squared. She just placed r. No, this is what it goes to right here. I'm going to put a little question mark here. We'll come back to that. Are you okay with believing that for now?
No.
No? You're not okay with believing that?
Prove it.
Give it to the third.
Yeah, it only works for the even power.
You sure?
Well,
What do you think? 0.
X squared plus y squared. X plus y plus z to the r.
X plus y plus z to the what?
R.
All over what?
X squared plus y squared plus sorry.
Is this correct? Like this?
Yeah.
Okay, so you know that this is less than or equal to 2 to the r times x squared plus y squared plus z squared to the r over 2 all over x squared plus y squared plus z squared. Do you agree with that? All I've done, I made the numerator bigger. If you make the numerator bigger, what happens to the fraction?
It gets bigger.
Do you agree with that?
Yeah.
Okay, so let's simplify this. We have a power of 1 right there, so this turns into, so you end up with this. F of x, y, z is less than or equal to 2 to the r times what? X squared plus y squared
Plus z squared to r over 2 minus 1.
to the what?
R over 2 minus 1.
Are you okay so far, everybody? To the r over 2 minus 1. This is huge. Yeah, we'll do some pieces here. Hold on. Then r over 2 minus 1 is less than 0, correct?
Yeah.
So the limit as x, y, z goes to 0, 0, 0 of x squared plus y squared plus z squared to the r over 2 minus 1 would go to infinity, right? And actually, so you can put that 2 to the r in there because it's static. It would go to infinity, right? Because 2 to any power is going to be positive. If r is greater than 2, then r over 2 minus 1 is greater than 0, so that means that the limit as x, y, z goes to 0, 0, 0 of 2 to the r x squared plus y squared plus z squared to the r over 2 minus 1 is going to go to 0.
You define that as f of x, not that.
Yes, but if I label that as some function, but that isn't f of x as we defined it. F of x for us is this thing is not that. It's the original one.
Yeah, I know, that's what I'm saying. Shouldn't we switch that to f of x then? Because we're not going to prove that.
Well, if this goes to 0, everything less than it is also going to go to 0, is what I'm saying. Got it?
Yeah.
So our answer, therefore, is what Ningi suspected, which is that it is continuous when what? R is greater than 2. The key to all of this is not the algebra we just did. The key to all of this is getting to here. That was getting to there. But what's the key to getting to that point? Making random substitution, which really is starting with this. This is not a question that I would give you on a test for a variety of reasons. The main one being you have to make a very clever observation and then apply a clever observation in a very, very clever way. There's one maneuver here. There's a maneuver we did twice, which is a very mature math operation for something like you, for students like you at your level, which is we were trying to find something right here. We were trying to create an upper bound that was pretty, essentially. We were trying to create an upper bound that was pretty. We got to here. We didn't really like that, so we turned it into
something bigger.
Now look, we changed this into something bigger so that we can make it all have a coefficient of 4. That was really nice because 4 was 2 to the 2, and that was nice because then when we did this really clever substitution right here, where we separated out, like here's the random substitution we said that 2 is equal to 2 times, 1, if it erases, 1 is equal to 2 times, r, I'm sorry. And this is being cranky, but that's just expected. R is equal to r over 2 times 2. That's like a random separation, right? How many different ways can you do that? You can do it r over 3 times 3, right? But because we did that, we were able to use the information we had and make the substitution. This is a challenging problem for many, many different reasons. It's not something that would go up on a test, but it shows you some neat things. Sometimes you need a clean upper bound. It doesn't really matter how much bigger it is, as long as the inequality holds. If you make the bigger side bigger, the inequality holds. If you make the smaller side smaller, the inequality holds. What happens if we make the smaller side bigger?
You're not sure.
You're not sure. If you make the smaller side bigger, you might have broken the inequality. You might not have. You don't know for certain. But you definitely know smaller side smaller is okay, bigger side bigger is okay. We ended up with some really, really, really nicely contracting algebra that's hard to see. What's that going to be?
That'll be f y over x times
Well, what rule are you going to have to use?
the product rule.
The product rule.
Yeah.
Right, so the derivative of the first times the second
Yeah.
plus
X times f prime of y divided by x
times what?
1.
So we're doing it's y times x to the -1, so you need the
Yeah.
derivative in terms of x, right? So what's it going to be?
It's going to be y
Negative.
negative y over x squared.
Yes, like that, correct? Do you agree with that? Does everybody see what we did there?
Yep.
Are we okay with that?
Yes.
Can we clean it up a little bit?
Not really.
Not really.
Not really?
I mean, the x
There's nothing? Okay, what do we get here? We get f of
y over x plus f prime.
f
No,
prime of
x cancels.
y over x times what? Oh, minus
Minus
y x to the what?
a1.
Is that correct? So let's just pretty this up just a little bit.
Make that
Y over x. I will. Minus y over x times what? F prime of y over x. Okay. I'm okay with that, so we know that xy is equal to that. Do me a favor, find gy for me. Do that right now. Find gy. Do that. Just write it down. We're recording. We need to take this thing right here. So this thing right here. So we have, let's do x minus x naught times that thing, right? But instead of y and x, what are we writing?
Why not? X not.
Exactly. So we have f of what?
Why
Why not over x naught?
Why not?
Minus y not over x not. Minus f prime of y not over x not.
That's part of it, right? I'm going to use the magic of the board here and only shrink part of it. So I'll have to write it again. But we have this, right? Plus y minus y naught of
Minus
f prime of
y naught over x.
y naught over x naught. Are we okay with that so far?
Yeah.
I kind of like that. That's kind of cool. I like that. Now here's the fun part. We get to rearrange this in such a way that,
They all
Equals 0.
yeah, we want this thing to equal 0, correct?
Yeah.
We'd like to see this thing equal 0. Because it's asking you, hold on, what is this question asking?
That's you to find when all the tangent planes intersect at a common point.
Show that all the tangent planes intersect in a common point. Z's all alone. There's nothing for z here. Let me just double check. Yeah, the z is all alone.
The z has to be 0.
Well,
Distribute
hold on, hold
Oh
it.
wait, no.
What? Say it. What?
Distribute the x naughts and the y naughts.
Yeah, so ready? And then regroup, yeah. So ready? Please tell me when I make the mistake because I'm sure I'm going to do something wrong. I got to make this nice and tiny. Plus,
Yeah, you just put y naught over y naught.
ooh, there you go.
You could just write this on 2 lines, so you don't have to write.
I'm going to probably end up having to do that. Plus x times f of y naught x naught minus x y naught x naught times f prime of y naught x naught, correct?
Yep.
Minus
X naught.
x naught times f of y naught over x naught minus
Plus.
Y prime.
plus, thank you, plus, thank you very much, plus what?
Y naught.
Y naught over,
Just y naught.
I'm just going to hold on, I'm going to do this out first and then we can start crossing stuff out, okay? And what's the last thing we need there?
Get the
F prime of, and that's the first half of this, right? Okay, so then what do we have here? Plus, oh, it's actually not that bad. There's only 2 terms, right? It's kind of nice. Plus y times f prime of y naught over
X naught.
minus y naught times
F naught.
f prime of y naught over, and I'm going to start using some highlighters now so you can actually see some stuff here. So where are our x's? We have an x right here and an x right there, correct?
Yep.
And we also have a,
X naught that erases.
yeah, we have an x naught that erases. We also have a y naught, correct? We just have this one, right? That's the only y we have. Do you agree with that?
And there's a z.
And then there's a z all by itself, correct? There's a z all by itself. So if we do this in order, x then y then z, with this, we end up with 0 is equal to x times what? X times what?
F of
F of y naught over x naught minus y naught over
X
naught f
times
prime of
Y naught over X naught.
1 over x naught. You got that, right? Is that correct?
Bracket.
Yep.
Close bracket, right? Is that correct?
Yep.
Plus what?
Y
Y.
times
Y times
F prime
f prime of
1 over x naught minus z.
minus z. So we've taken care of this. We've taken care of this. We've taken care of this. We've taken care of this and this. What happens to the rest of this stuff?
Cancel.
Yeah, there's a magical thing that happens right here. This cancels with this, right?
Yep.
And look what happens here. This cancels with that, which turns it into,
that.
and that goes away completely, right?
Z equals 0. you
Look.
go-
Oh yeah.
That all the blue cancels. Do you see that right there? all the-
How did the all the way?
Okay, so ready. This right here cancels with this one. Do you agree?
Yeah.
Okay, so look right here. There's an x naught and an x naught that cancel right there.
Oh.
And you're left with y naught times f prime y naught over x naught. And you're left with the same thing right here. So this cancels with that. And you're left with this thing right here.
Since the
Always
intersect is 0.
intersects at 0, 0, 0.
Wow.
Pretty cool, huh? And the way they say it, but any plane whose equation is of this form passes through the origin. Must always pass
Because you know that.
through the origin.
Oh, I
Cool,
should
huh?
probably tell you, Mrs. Coburn had me fix your